Yes, hello, welcome to the episode 3 of NischiCodes, and today we are going to solve a brand new DSA problem, that is lead code 169 majority element. Okay, so let's solve this problem. Lead code 169 majority element from the beginning, and we will first read the problem as we do in every condition problems that we are taking up right now. So given an array nums of size n, return the majority element. So given an array of size n, so suppose n is some number that they have given us, return the majority element, and they have given the definition of majority element. The majority element is the element that appears more than n by 2 times, that is more than half the times it appears. You may assume that the majority element always exists in the array. So they have told us that the majority element always exists in the array. So suppose my n, the length of the array that I've got, is equal to 5, then my majority element should occur at least 2 or greater than or equal to 2. Greater than or equal to 2, my majority element should occur. So suppose my array is 1, 2, 1, 3, 4, then my majority element is 1. I majority element is the most frequently occurring element that is present in the array. So let me just, so yeah, so let's get back to this. I got my mouse in hand. So yeah, first example that they're given is a array with input size of n equals 3, and the elements that they're given is, let's just check this. The input size of the array is 3, 3, 2 and 3, where n equals 3 is what they've given. So the majority element is an element that should appear at least 3 by 2 times, that is equal to 1 time. So minimum of 1 time this element should occur, and it should be greater than or equal to 1. So when we count the frequency of the elements here, so 3 occurs 1 2 times and 2 occurs 1 time. So it should be greater than or equal to 1. So 3 is occurring at least 2 times. So then we can easily say that the element that occurs the most is 3, and the majority element should be 3. Next, if we go to this array 2 2 1 1 1 2 2, so here the element 2 appears 4 times, the element 1 appears 3 times, and the size of the array is 3 6 7. So it should be a minimum of 3 and maximum of 4. So 4 elements is that is the frequency of 4 is 2. So the majority element should be 2 here, is what we can get from here. So now let's look at the constraints that they've given here, and as I tell every time, constraints is very important in lead code. So n is nums dot length, that is fine. 1 less than n less than 5 star 10 power 4. So it should be around 50,000 elements will be given in a particular array. And the array can be from the size of the element value can be from the range of minus 10 to the power of 9 to the 10 to the power of 9. So 2 to the power 10 to the power of 9. So the best solution for this problem would be using an algorithm called as the Moore's voting algorithm. So before discussing the most optimal solution, let me discuss the brute force solution. Then let me discuss the better solution, and then we'll go to the optimal solution for this problem. Okay, so let me start with the brute force solution. So in the brute force solution, what can I do? First, take 2 to 3 seconds and then analyze what can I do for the brute force solution. Just think, the brute force solution is always, the brute force solution will be involving traversing through the entire array. Somewhat the other reason it will be something called as traversing the entire array. So what can I do? Just think for 2 seconds. What can I do? Now let me clear this canvas and let me draw an input array of my own. Input array of my own. 1 1 2 2 1 3 1. So the majority element clearly is 1, right? So now first let me go with the brute force approach, that is big of n square approach. Big of n square approach. And so in this what I will do is I will run and I'll pick an element 1. Very simple logic. I will track a variable called as cur, and I will initialize it to array of 0 currently. Okay, I'll initialize it to array of 0, and I will loop through the entire array. Then what I do, I'll also keep a count variable. I also keep a count variable. So once I find the array element to be present in the arrays, for example, I find one here, I'll increment the count using count plus plus. Then I move to the next element, I check whether yes, so I increment the count to 2. Whether this is equal to 1, no, then I skip this. Whether it is equal to 1, I skip this. Whether it is equal to 1, yes, so I then override it to 3, skip this, then I override it to 4. Then I'll write a very simple if condition that suppose this count variable is greater than or equal to n by 2, then return it immediately for me is what I will write. So let me walk you through the brute force approach now here in Java. Right. Int n is equals to nums dot len, that is clear and cut. Int count should be equal to 0 and int cur should be equal to 0. Let me loop through this through this array now. Let me loop through this array right now. So once I loop through this array, let me take cur equals nums of 5, or what I can do here is I will initialize this to nums of 0, right? I can initialize this to nums of 0 and then I can proceed. Let me think this out loud. Let me think this out loud. How can I solve this? So there's some issue with the initialization of this. So let me write this comment first. Calculate the frequency / count for each element. And next, let's move to the next one. Okay, so I'll declare one more variable called as majority. And wait a second, let me check what can I do this. Let me declare a variable called as majority element and declare it to a size of n by 2, right? Because once I told this if condition, right? If condition, if it is greater than or equal to n by 2, so the size of should be n by 2 itself. So I'll declare it to a length of n by 2. So now I'll run an extended for loop for int num in nums and count equals 0. So num is a iterator variable that we are using here. Let me run one more loop because it's a big O of n square. So big O of n square is at least 2 loops should be present here, right? So int num1 in nums, right? If num1 equals num, then I simply increase the count variable. And outside this for loop, I will check if count is greater than majority element, then return count or return majority element, sorry. Return majority, okay, return the particular number. Yeah, I require the number, right? So I return the number 1, else I return a -1. Default case. Understood? What am I doing here? Very simple. I take this variable majority element, I take this and I initialize it to a size of n by 2. This is what I want. If the majority element should occur greater than n by 2, so I initialize only, initialize it to n by 2. Then I run through this loop using a extended for loop using a iterator variable called num. So, and I store a variable called as count, right? So once again I run through this loop. So first loop is right now here. So second loop will check this. If it is yes, then increment the count. Next it goes here. If yes, increment the count. Next. So if the second loop equals first loop, then increment the count. And if the first loop count is greater than n by 2, then please return the following number. So let us test this solution. So let us test this solution. Yes. So this is a brute force solution. Let me see. It will be very suboptimal. Let me just check this. As you can see, it beats only 8.38%. So we need a better solution. And before we jump on to best solution, right? So let me draw my input array once again. 1, 1, 2, 2, 1, 3, something like that. Yes. So this is my array that is given currently. So what new approach can I think of? So now what editor is traversing that kind of entire array, right? So what new approach can I use? So I know that the basic principle behind this entire problem is calculating the frequency of each element. So the basic principle behind each of the element is calculating the frequency of each element. So once I hear the term frequency in Java, I directly go to the concept of hash map. Hash map. So let me just start this. So let me go here, hash map, right? So first declare the nums dot length, then let me declare a hash map of type integer, 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 and let me name it as map, new hash map, right? Now again I'll take this majority element loop as n by 2 itself, n by 2, and again I'll run an extended for loop for in nums. Next, if map dot contains, oh, what can I do here is, let me initialize num with map, map dot get, map dot get or default, map dot get or default, the same number, the same number plus 1. So what am I doing here is, very simple logic. So this is a big of n solution, so I need to run only one for loop through this entire array, right? So what I'm doing here is I'm keeping a iterator variable num that is going through this entire array. So what am I doing num only? I'm just overwriting the num value with, if this hash map contains the value 1, then initialize, if this hash map contains 1, then initialize that number with the current num count, that is 0 plus 1, that is 0 plus 1. If there is no count, for example, if I encounter a 2 and there is no count that is seen before, initialize it the default value of 0. Initialize with the default value of 0. Okay. And yeah, just give me 1 second. I can take this as int count. Instead of just overwriting this, let me initialize one more variable, count, as the count equals map dot, yes, absolutely right. So if count variable is greater than majority element, then I will return the num, else return, I'll return the num, yeah, else I'll return -1, not the majority element. Majority element just gets the count. The number that we want to return is num. Let me see what is the issue here. There is some error that I am seeing here. Let us debug this. Let me think out loud what is the issue that is currently in this solution, and then we will debug this. So I've created a hash map, correct, then I'm trying to store this, correct, 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 correct. Okay, always this count should be initialized within this for loop, that is should be right. And the count variable, if you're initializing it outside the loop, then it always gets overwritten by 1. That is because I forgot one key logic. So I'm trying to get the value if it's present in the map, right? Map.get.default, but I'm not putting the value back into the map if that value is currently not present in the map. So what I will do, I'll put the number and the count, that is the key value pair, and then I will check this. Yep, absolutely perfectly it worked. So we have to just analyze this. So this is the hash map. So suppose I view the hash map as this. So it will contain such thing, something like key and value. So suppose that key is present like 1, 2, 1 something. Then I increment the value by 1, 2, etc. Otherwise, I'll decrement the value to 1 itself. So something like this will do. And now this is getting a better optimal percentage, that is 37.6. And because we are storing it in a big of n. But the examiner or the interviewer will ask you, definitely tell me the best approach, and the best approach here definitely is the Boyer-Moore voting algorithm. the Boyer-Moore voting algorithm. So int n is equals to nums dot length, right? Next int count equals 0, int majority element equals 0. So I will explain the code first, then we will look into the logic behind this. So if count is 0 currently, then replace my majority element, or replace or overwrite my majority element, the current element, and increment the count, count, or set the count to 1. Yes, set the count to 1. Next, if count is equal, so okay, if major nums of y, current element, is equal to the majority element, increment the count, else decrement the count, and return me the majority element. Excellent, 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 excellent. So we will look into this solution right now, and then I'll let you know, guys, what is the exact thing. 1 1 2 1 is my array. So what does the Boyer-Moore voting algorithm do? Does is it tracks two variables, count and maximum element, what I do is this to solve this algorithm. This solves this algorithm uh, in, if I'm not wrong, a big O of n approach itself. You can use the same as hash map, but the main thing is with the space complexity. It takes a big O of one space complexity because there are no auxiliary or additional structure that you need to put here instead of the original traditional array. So what I can do is like keep a variable count and maximum element. So I traverse this entire array using a iterator variable for. So what I track here is if my current element is if the first condition is if the count is 0. Assume the count is 0, so this element has not previously been tracked by the array. So what I do is I will set this maximum element. I'll assume this is my maximum element because I'm going to get a count of 1. So I'll initialize this maximum element with this nums of I, and I set the count to 1 because I've already counted this. Next I check the second element. So if the second element is equal to the value of the maximum element, then I update the counter. Then I check the third element. If the third element is not equal to this thing, then I decrement the counter because I've not found it once again. Again, I do the same thing and I increment the counter back to 2. So what I've done is after doing this, I got a count of particular 2. So if I do the same thing with 2 as the first element, then I get a count of only 1. So 2 is greater than 1 and 2 is appearing at least n by 2 times in this array of n equals 4. So we can easily safely say that 1 is appearing at least 4 times. So we can safely say, sir, 1 is the majority element in this array. So the Boyer-Moore voting algorithm is the most efficient and most sufficient optimal algorithm that is required because it runs in a big of one condition. So now they have given us a beautiful edge case that we have solved out up to 48 or 54 test case passed. So let us check what is this. Let us check and I will debug it with you guys only. For count 0, majority element is 0, fine. Yeah, what I can do here is let me try out this thing. Majority element, I will write it as the smallest value that is present, right? That's the smallest value that is present, and I will now, okay, okay, count minus minus count is 0, that is also then fine. 48 after 54 only it is there currently. What might be the issue, we will just see right now. Majority element, okay, nums of my uh, what can be the issue, what can be the issue, let us just see what can be the issue. Correct, wait a second, let me just see. Let me just see. I think I do not need to reset the count here to 1. It will automatically take the count as 1 because when I'm incrementing it to count plus plus, it can do this. I think let us just check this, check it with this. Sometimes too over complication of the code also matters. Absolutely correct, we have taken a 99.89% optimality here, that is it beats 99% of the test cases that is given. Big of n time complexity, big of 1 this thing. So the first is the brute force solution where you traverse through the entire array by taking each element and then checking if it is greater than n by 2. The second approach is using a hash map. The third approach is using the Bohr-Moore voting algorithm. Please remember, this is a very common interview problem in most of the FANG and MANG companies and all the other companies that are present here. So always try to check and tweak with your code if there are certain edge cases that are not passing. Thank you so much, and let's meet tomorrow. And tomorrow we'll have a surprise system design question also that we're going to solve here on NischiCodes. Thank you so much. Bye bye.